Hello, this is Team Aspect Ratio, and today we're going to be showing you our OTV. This is a pretty low quality photo, so let me show you a better quality photo on the next slide. Oh, never mind, that is not the best quality photo. There we go. This is our OTV. This was able to accumulate 40 points out of 120 by navigating past all the obstacles to the final destination zone. And as you can see, there's a lot going on. So we made a CAD model for us to run through it real quick.
Oh my God!
So here's our CAD model. As you can see, the main part is our chassis. Our chassis has a laser cut top, and then it has dowel rods in between. These dowel rods are hot glued because the laser cutting allowed there to be a little divot for it to sit in, while these dowel rods that are extended off of it actually are screwed on. Next, we have two Arucos. One of these Arucos was for our navigation, while the second one was to be dropped at the mission site as part of our mission. Next, we have our breadboard. This breadboard was planned to be replaced as a soldering board. However, we realized there's no need. We can focus our energy elsewhere. So we stuck with our breadboard, and it was really useful in getting power to all of the parts we needed. Next, we have our Arduino. As pictured, there's Arduino Uno. However, we did end up switching to a Mega in our later runs, but in our most successful run, we did in fact use an Arduino Uno. Next, we have our motor controller. This is a really pivotal. This is a really crucial part of our design, since without it, we would be able to go forward and backwards. Next, we have our electromagnet and holder. The electromagnet was bought off the shelf, however, the holder was in fact 3D printed. This will be our first 3D printed item of the day. Next, we have the height apparatus, which includes the servo holder, and IR sensor. This was all off the shelf. It was really useful to have the holder be off the shelf since it fits perfectly with the servo, and this IR sensor was a pretty late addition for us to measure the height. Next, we have 4 axles and 2 axle holders. These axle holders were also a 3D printed aspect that we designed, and all of these 4 axles were a combination of screws and soldering and hot glue to get these wheels to be snug to the axle. Next, we have the mission apparatus. As you can see, it's off the edge with the dowel rod because the color sensor needed to be very close to the box to sense it, but we have a 3D printed holder for the color sensor, a purchased holder for the IR sensor, and then of course both the sensors were purchased. Next, we have 2 motors and 2 motor holders. The motor holders were 3D printed, however the motors were purchased online. Next, we have 3 ultrasonic sensors and holders. The holders actually came with the ultrasonic sensor, so it was really nice. It was a great snug fit, and it was really easy to put onto our OTV. Then we have 4 wheels and 2 belts. So the wheels we bought online, we also bought the belts, however the belts didn't need to be adjusted to fit around the wheels snugly. Alright, so to begin with the parts that we created, this is our electromagnet holder. This was designed in CAD and 3D printed. As you can see, the electromagnet fits right in here, slides down, and then is held snugly by this design. Additionally, this is a 2-in-1, where this was cut out to actually hold the battery. So this is a really cool part. As you can see, a lot of detail went into this design. Next, we have our axle mount. Pretty simple design. It's very similar to our motor mount, which we'll get to in a little bit. Basically, it just holds the cylinder of the axle right here. It gets screwed in. And yeah, pretty simple design. Next, we have the color sensor holder. This one, very similar to the electromagnet, where the sensor just slides right in. As you can see, this is the perfect dimension of the color sensor, and it's slid down with just enough space on the top for the pins to go out and for the color sensor to be held very snugly by these little parts jutting out, like right here, right here, right here, right here. Very great design. This was also just like the last 2, designed in CAD and 3D printed. Next, we have the motor mount. This one, very large cylinder that holds the motor. Very cool part of the design is on this side, it has a little jut. If you can see it right here, it's all the way open, but on the other side it actually closes a little bit, so that it has a little bit more of a snug feel, and has this part at the bottom to make space for the turning axle. And just like the axle mount, it's also screwed in. Next we have our chassis. So our chassis has dowel rods and plywood. The plywood was laser cut. The laser cutting allowed it to have little indents in it for it to hold these dowel rods. These dowel rods, of course, connect the plywood. However, these dowel rods extend off of it to hold mission apparatuses. So this one holds the servo, and this one holds the color sensor and the IR sensor. Finally, this is our entire OTV as a drawing. Overall, it's a little bit under 9 inches wide, with the chassis being 6 inches wide. Just under 6.5 inches tall, with our chassis being 4 inches tall. And about 14.5 inches long, with the chassis being 11 inches long. So, that is everything that we designed as a team.